Hello everybody, I'm Scott Carson,
And I'm Shrija Sundaraju.
and this is our final presentation for our final project for BME 462, fall of 2014. Srija's going to start off.
Our project is based on using EMG for muscular rehabilitation and training. It's a common medical practice used in different situations. One common application is recovery of nervous system injuries. Sometimes during a stroke, nerve cells can be disrupted. In case of a traumatic impact, the neuromuscular pathways can be restored. Our idea would be that a strict rehabilitation training plan can restore the damaged pathways. Usually, the rehabilitation stage and recovery stage are performed separately. This can lead to multiple trips to doctor's office. Another problem is that children may forget or may not be interested. We have designed a system based on an interactive computer game. The game includes an external circuit consisting of two EMG sensors and a microcontroller. We have two-channel EMG circuit designed. This circuit includes an adjustable gain amplifier so that it can be used by different people effectively. An embed microcontroller is used to acquire and process the signal and to send it to the computer. For the game, a program is written in a Java-based IDE called processing.
So I'm going to take us through the circuit right now. So on the screen you can see our schematic that we made in Altium. The main parts of the circuit that you want to be concerned with is in the lower left corner. That is our instrumentation amplifier. There's two channels in the one IC. And then we have two mirrored circuits you can see in the upper right and lower right corners of the screen. The main parts of the circuit are the rectifier, which I am circling right now with my mouse. And then we come down and we actually have a enveloping circuit. And then we have a 60 hertz notch filter. And then we have a programmable gain amplifier at the very end. And this is the same for both channels. We also have an ACOM generator because we are powering this circuit with 3.3 volts. And the ACOM generator outputs about 1.65. Here's a picture of our PCB design that we made in Altium as well. The PCB was made, it was 2 inches by 3 inches, and you can see that again the circuits are mirrored at the top and bottom. It is a two-sided board with the power plane or VCC on top and ground on the bottom. Unfortunately, we had some issues with the manufacturer and our PCB did not get shipped in time to have it ready for the demonstration. Because of that, we developed a breadboarded version of the circuit. It is only a one-channel version of the circuit. However, it worked well for a proof of concept and our prototype. So here on the screen you can see our breadboarded circuit as well as the embed microcontroller that is hooked up to the computer. Everything is powered directly from the embed, so there's no other external power source. Looking at some of the results of our EMG itself, we're going to go through a couple different oscilloscope screenshots. The screenshot you see right now is of the raw EMG signal after it comes out of the instrumentation amplifier. So it is not rectified, and you can see it is fairly noisy. Then we rectify the signal, so you can see that everything is positive in comparison to the ACOM. Then we envelope the signal, which does decrease the amplitude a little bit, but it also gets rid of some of the high frequencies. And then finally at the very end we put it through our programmable gain amplifier, and you can see that the peak to peak that we get is about 1.11 volts, which is plenty for the microcontroller to tell. Hey guys, this is the beginning of our demo here, so I will go over the game a little bit more in detail when we have a closer up view of it, but I wanted to show you it live in action. So I'm going to start a new game. So here you can see our little golf course. This is the only level we made. And if you can see the ball in the bottom portion of it, when I flex my forearms, I'm going to move my hand down. The ball moves, and then it slows down. So now I can try it again. And I made it. So now I'm going to do this one more time, just to show you. So if I only flex a little bit, or for a really short amount of time, the ball doesn't move very much. But if I flex for a little bit longer, that one was a little tough. Now the ball will go all the way down to the end. So this is how you could use this as a training tool. So here's a demo of our game. So here you can see the main screen. We have a new game button, a high scores button, as well as an exit game button. The high scores button is not implemented yet. However, if this was going to be a tool used out in industry, you'd want to implement this because this is how you would be able to tell how far a patient has recovered. But that being said, we're going to start a new game here. Here you can see the basic golf course that we have right now. Something we'd like to improve in the future would be to add a couple more golf courses in to keep it fun and exciting. But this will prove our concept. So when I flex my arm, this is hooked up to my forearm right now, the ball will travel, and you can see it didn't go very far that time. Now when I flex my arm again, it'll keep traveling. Again, not very far. Now if I try really hard, it goes further. So this is how someone could train themselves to use their muscle better and be able to contract for longer. And you can see once I make it, I'm a winner, and it took me 5 hits, and it brings you back to the main screen. So now let's see if I can do it a little bit quicker. So if I try really hard, I can get it about halfway. Let's see if I can get it to the end. Almost. All right. So, it ended up getting there in 2. So that is the basics of how the game works. And so, in conclusion, our project did work well. We ran into a couple issues with our PCB, and we would have liked to have had that for the final project. However, we were able to complete the circuit on a breadboard. In the future, we'd like to add a couple improvements to the game, including a couple features like the high score feature and maybe some other levels to keep maybe a child's interest or a patient's interest. Looking at improvements in the circuit, we could do a little bit better job making it able to be calibrated for different users. We could also do a little bit more smoothing to get rid of some more of that high frequency noise. Here are our references, and thank you for watching.